All right, so welcome to the second lecture of the beginner lectures for competitive programming. Before I start today's lecture, which will be on arrays and sorting them, I'd ask you to please scan the QR code. The link in the, which side is it on?
Yeah.
It's on this side. I don't know. So scan that because we want to make sure who's attending, that we have that all on file. I'd also like to point out that we are pushing out daily leak code questions. They're not mandatory. However, you do it and you learn. That's also, you're going to save it on your leak code account. So you're going to have your submission saved and you can reference your previous work. It's also collaborative, so we learn from each other. We see people with better answers, better explanations, and we grow when we work on these problems. These problem-solving skills of yours will grow in that respect. Also, I guess I should point out that on the Discord, please make sure that on dev communities, you do have the role assigned. The role is called the competitive programming. So there's going to be a little text, and there's going to be like little emojis, emoticons, and you're going to want to click the competitive programming one so that you're up to date on our events on the Discord server. All right, I think, yeah, that's pretty much all I wanted to talk about. And today we're going to talk about arrays, and yeah.
How do I connect to your Discord server?
Okay. Yeah, so if you don't have our Discord server, you can go to DSC FIU on our website, and we have the link to everything there. You can get inside get our membership form, sign it, and the link to our Discord. Okay, and now I'm going to discuss arrays. So what is an array, right? So we know variables like ints, we know variables like chars and booleans. So those are singular variables. They store one piece of data and that's it. But what if we could have a collection of data? So an array, say an integer array would be, well, this is C code, but this would be how you instantiate it. And I'm going to put random number 42. Okay. So an array needs two things: the type declaration, the variable name, of course, for the array, and the size. So it needs all the members of the array to be of the same type, all of them. In Java, in C, C++, they all need to be either int, or you could say Boolean, whatever. It needs to know what each member, how much data needs to be stored in memory for that. I'm going to go back to int though. And then here we have how many elements. So it does need to know everything so that it knows how much memory to allocate in the RAM for the program to store the array. And we also know that when you want to get a member of the array, it's numbers. So 0 would be like, it's the first value is R0. That bracket. 41. Okay, so it goes from 0 to 41 in this instance. It goes to, it's 0 index. So it starts from 0 and it ends at the size -1. Okay? And yeah, those are the basic things about arrays. In Python, it's a little different. In Python, you don't need to declare type or even the size. Python has lists. They're not exactly arrays. When I'm going to write the pseudocode, it's going to be Pythonese. but we're gonna like try our best to like keep this concepts in mind when I'm writing the code. I'm gonna make it clear that this is important to keep in mind. But yeah, in Python, you don't have to do type declaration or even give the size. But typically, when you do work with arrays, you do. So I'm gonna erase this. Okay, so let's say I had an array of integers like this, 4, 2. I don't know. Right? See, I had an integer array. I'm gonna call it R, whatever. And this is how one will look. You have a number of integers, and each would have a value. So how would you say order this? Sort this from smallest to biggest. I mean you, like not the computer. Like if you did it by hand, how would you do it? Okay, how you?
Okay, you would look at all the elements in the array and like basically pick the smallest one, then do the next smallest one.
Okay, where do you put the smallest one?
So in the beginning.
Okay, all right.
Like
So hello.
this.
So you're saying get the smallest one, right? So you go through the whole thing, and you find the smallest one and you put it here. Is that what you're saying?
Yes, yes. So it
Okay.
would be 1 in this case.
Okay, so then you would say swap 1 with that value that's there.
Okay, yeah.
Okay, like that. And then you just keep going.
Yeah, right. You keep on. Yeah. So the next smallest one is 2, so you swap it with 8.
And of course we ignore this one.
Yeah.
Okay, so we go with 8 and then swap it with the smallest one we find, and it's 2.
Right.
Right. Okay. Okay. So that's what one person in the crowd said. You have a question?
It may be faster to start from the middle, like divide it in half.
Okay. Yeah, I'm gonna get into that, but I'm actually glad he brought this one up first. So that's one solution. That is a naive solution because, well, it's like it sounds like an easy way to do it, right? So how would you write code for that? Actually, which algorithm is that?
Which algorithm?
Yeah. No, I don't.
I
It's
don't know.
not
My
in
mind
systems.
just went blank a little.
How you would do it if
Yeah.
that's selection, isn't it? Or bubble?
Well, bubble, actually, we get into bubble. So bubble, I'm gonna put some random values here. 9 and 3. So bubble actually,
Oh wait, yeah, I remember.
yeah, okay.
Someone in chat said selection sort. Yeah.
Okay, yeah, it is. That one is selection sort. Before I go into selection sort, I'm gonna go into like bubble sort. So in bubble sort, what you would do is you would have this much of the array, right? And then you would be, so for going through the whole list, you would be continuously swapping until you reach the end, right? And then you would ignore the last part and just keep doing it the whole time. So selection sort is different from the other one. So you're going to keep doing swaps. You're going to do n squared swaps, and I'll show you why. But when it comes to selection sort, you're only doing n swaps, which makes it a slightly faster solution than bubble sort. But you're going to see that they're both equally bad. They're both equally bad solutions. You had a question? No? Okay. So Selection sort is n swaps. Bubble sort is n squared swaps. So we were doing that. So what's the algorithm for bubble sort? So I'm gonna write here. So for I in this is Python, but you know you could do it in any language. And then for okay. So for I in range, you know the length. So then for j, up to, you know, the last element. And of course, every time we're going to go down, we're going to find, hello. You know, we're going to keep on decreasing the size of the array. So that's what this is. This I keeps growing, so you're going to keep decreasing the size of, you know, the problem we're working with. And so we say if so if the value is greater than the one after it, then swap. And does that make sense? So, yeah.
Sorry, I have a question. So for the inner for loop, why is it 0 to n minus I minus 1?
So basically, this I, at first this I is 0, right?
Okay.
So then this is going to go to n minus 0, then minus 1. So n minus 1. And the n minus 1's value is this one.
Oh, okay.
And
okay.
we're going to try to not index that value, because here, if we index that value, it's going to be plus 1, and you're going to go over the limit. So we're going to go up to, you know, before that. And that's what the point of this is. Also, the other point is that since this is growing, that means that once we finish with this, we ignore it the next time we loop. Does that make sense? Okay, is that confusing? A little.
Well, maybe just to make sure, so let's kind of go over it again. So you're going from, so you were saying the last
Okay, yeah. So I goes from 0 to n minus 1.
Okay.
This value I goes from 0 to n minus 1. But for each I, right, j is going to go from 0 to n minus, well, actually, it wouldn't be n, at first it would be n minus 2, at first. But then as you keep going, as I keeps increasing, it'll become n minus 3. Then when you loop again, n minus 4.
Okay.
Right, because you keep on decreasing the size of the problem you're working with. So that's what the point of this is.
Okay, okay.
So yeah, that's why the I is there. Okay? And so you're going to do, if, you know, the value is greater than the one after it, you swap. So it could be that you have to like do many, many swaps in this one. So one thing he was suggesting is, instead of doing this, let's find the minimum or the maximum, it doesn't matter, and then just, you know, swap it, right, with the first value that's in the list. I'm going to erase this.
Oh, I'm going to take a picture of it.
Okay.
Do you mind?
That's fine. Well, I mean, the live stream is going to be on YouTube, so you can reference it again.
Oh, yeah,
Yeah?
that might be better. Okay.
Okay, all right. So this is, I didn't write it at first. Okay, yeah, this is bubble sort. Okay, there, and that's the thumbnail for the video. No, I'm just kidding. We make our own thumbnails. Okay, so what he was saying before was to get them in and put it in the first value, right? So that we don't have to do so many swaps. And that is selection sort. We select them in. Okay? So we're there. And so we
So
loop.
the one that you just showed us, was that bubble sort?
Yeah, the
The
one
one
before.
you just erased.
That one is bubble sort, yes.
Oh, but you said that this and selection sort, like they're just as bad, in other words.
They are just as bad because you're doing two nested for loops. And that's the
Oh.
main reason. You're doing
I
two
guess
nested
so
for
as
loops.
far as time complexity, like
They are the
that's why
same.
it's bad.
They are both O of n squared. Big O
Right,
of n
yeah.
squared, selection sort, and bubble sort are just as bad as each other. And let's see if I have any questions here. Okay. Okay, no. All right. So anyway, we have a new array, right? Well, it's the same. So what he says, find the minimum. So how can we, tabulate that? How can we store that? Well, since we're going through index, right? We save the min index and we say it is I. We're starting with I. For j in. We start at I, go to, I call it A. And I plus 1. Okay. So for j in range, right. So if okay, so before I continue, you can tell me what's happening here. I'm not done with the algorithm.
You're just picking the first element at first for I,
Mm-hmm.
storing that in a variable, and then you're going to run through the rest in comparison.
Sort of. That's not really what I'm doing. Well, we're starting with I, right? We're starting with here, and so we're starting with here, right? And then we're going to loop through all of this. And instead of doing like before, we were doing many swaps. Now we're only going to find where the smallest one is. So apart from this one. So see, that's this loop right here. We're going I plus 1. We're starting at the one after this. So then we go to, of course, to the length. And now we're trying to find where the minimum index is. So basically, if the R min index, so if this value is smaller than, well, the value that we're at, then now the minimum index we find there is going to be equal to j. That makes sense? So we're trying to find where the smallest one is. And as soon as we find it, we swap. Okay, and I'm just going to do. Okay, I wrote my swap a little differently from before. But I hope it's still clear what I'm doing, right? As soon as I find the minimum there, we swap. Is that right? Okay. 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 So, any of you got a question, Les?
No, it's the swap because it's different from the other one.
Okay, I'm just saying this is the array, and these are the indices of the array that we're swapping with each other.
Do by indexing, like have two parameters.
Okay, it's just a lot of writing. I did it like that to do less writing, but fine.
Wait, it's less writing.
No, it's not. It's really not. I have to write another R.
I thought that's true.
But I'll satisfy you, and I'll write the whole thing. Okay, happy?
Yes, thank you.
Are you satisfied?
Super.
I am. Okay, see, I did it for you. Okay, is that clearer than the other one, or do you prefer the other one? What do you?
I like that.
Do you like this one?
That was great.
Damn it. Okay.
Well, either one is fine.
Either one is fine.
For me.
All right. Well, I'm seeing more hands for this one, so I'm gonna do this one, I guess. Whatever. So we swapped those values. Okay. Now, okay, you have a question?
I'm sorry, it looked like you were done with me.
I don't know. You keep doing this.
No, yeah, I was going to suggest
Mhm.
if you can run that algorithm with the given array example.
Oh,
So
okay.
you can see how it works.
All right. So okay, I want to make sure this is visible. So okay, so we start here, right? This is our. Actually, maybe I'll use another color. So our I is here, and let me use another color as well. Use green. J is here, and we're gonna store a min index somewhere. So our first index is I, right? So now we're at J. J starts at I plus 1. This is I plus 1, the one after it. Okay? And so we see, is this value bigger than this one? No. So we don't change it. And then we move it up. And we do the same thing. And I mean, I'm just going to, none of them are smaller than this one. J is up to here. J is done. Actually, J is outside. It's done. So now we find out that we have to swap the value at min index with the value at I. They're the same. So it swaps with itself, and that's it. It stays where it is. That's where it belongs. Close that for now. So now we move I up again. Okay. And now we're here. We're doing the same thing. And J is back there. Yeah, that works. So now we have to compare J with min index, which is I. And this one's bigger, right? So now we have to change the value to the value that J is at, which is, well, actually I have to put the actual number. This is array index 2. This is okay. That's why I'm putting 2. Okay. So I changed it that time. We move it up. Now we're here.
Excuse me.
Okay.
So you put 2 twice, like because you swapped them, right?
No. This is a 1. This is a 1. This is a 1. This is a 1. Maybe I'll just put it like that.
Yeah. Oh, I thought it was a 2. Okay.
All right. It's not neat handwriting, I know. Okay, so now we compare 5 with min index is 2. So that's here. So it's smaller, right? So now we change it again. It's a 3. It's 3. Then we move J up again. Okay, so now we're here. And we compare it again. This is smaller. So now, coincidentally, they're both the same. The value and the index. That's just a coincidence. Move it up. Okay, compare that with min index 4. It's not greater, so it stays the same. So now we have to swap the value at I, which is 8, with min index. So because this is the smallest one we found apart from, this section. Okay? And so on. This is going to take long if I go through the whole thing. But does that make sense so far? Any questions about this?
The question about the pseudo code. So in your second for loop, right, you have the range I plus 1, right? So you're doing that so that you don't have to go back to the value.
Yeah, exactly. So you're starting from the one after.
So how does that affect, like if I wasn't to put the plus 1, how would that affect how fast you go?
Well, actually, it wouldn't. It's minimal. I mean, all in all, the runtime is still going to be quadratic. This has less swaps. Well, actually, not really, because you do have to overwrite this maybe an n squared amount of times. Min index has to be rewritten again and again. Does that make sense? Okay. So selection sort and bubble sort are both big O of n squared, right? So that means that depending on the size of the array, the runtime will be the square of that. So it'll be 25 for, no, this is 6, 36 for the size of this array. Can we do better than this? Is it possible that we can improve something like this so that we don't have to get an n squared solution? Because it works, but it's not exactly efficient. So is there a better solution than this?
Before going on to this, because I know you said selection sort and bubble sort is bad.
Yeah.
And you also mentioned the bubble sort is worse. And Clement in the live stream asked, why is bubble sort the worst?
Well, bubble sort is worse because you have to do many swaps. Like I did before, I had to do this, and then, you know. So basically, the first value is compared n times. Like you look at this value, n amount of times. And that's how it was before. But no, I mean, they're really about the same. They're both n squared. They're both equally bad in terms of how they grow. As the problem grows, the time taken to solve it grows about the same. So yeah. Okay, so I asked, like, is there a better solution we can do than either of those? Okay, you have a question?
If you divide it in half and search for a large number in the first half, if it doesn't exist, then start on the next half. Or if you find in the first half, that can become the newest largest number. I mean, smallest number there. And then you just compare that to the second half.
Compare that. So you cut it in half and try to look for it.
Yeah.
Well, could we cut it more in half when we cut it in half again?
Yeah.
Okay. So, what is it, 6? Okay, this is 6. This is 6. Okay, this is 6 values. All right. So good, good. I'm actually glad this is only 6. That means I don't have to cut it in half so much. Okay, so someone in the audience, in the live audience, was saying that we should cut the array in half. You know, do you know what the concept is to divide the problem over and over?
Divide and conquer?
Yeah, it's divide and conquer. So imagine we could divide the problem into smaller parts, and solve it from the smallest part, and build our way up. And that's basically the idea. Yeah. So we're gonna go on to the new one, the one that we're being introduced to is merge sort. Okay. All right. So what you do with merge sort at first is that, like what he was saying. Actually, let me do that instead. Okay. So we keep dividing it in half. and this would be my bad. And yeah, I'm not gonna have enough space to write solution here. Okay. All right. This is what I did, right? We break the problem up into half until we reach the base case, which is that now it's a size 1. When it's a size 1, well, you can't really do anything. It's size 1, and you can't really do anything with size 1. So then once we reach, say 2, that's when we can do work on it. So I'm going to pick 9.8. So I'm going to work with 9.8. Okay. So basically need to, well, to begin with, before we did 9, we go back to 9.8. We have to see that it was broken up into 9 and 8, right? So before it was 9 and 8. And we can see that in a way these two are lists. Each of these are arrays with values in them. So now on the side, I'm going to do with red. I'm going to make an extra array, right? And on top of that, I'm also going to have, say, I, J. And, okay. So what we do is that we fill this new array in order. And at the same time, we're also iterating through both elements. So we find which one's smaller between I and J. J. So now we fill it up with this one.
Sorry, I don't mean to interrupt. Before we continue, I want to ask, like the second time we divided it, like when we had 3 and 3, like how did we further divide it? Because 3, like half of 3 is not an even division.
I didn't. I'm not dividing 3. That's the thing. I'm just kind of, so I'm just doing it so that, like, it kind of just, this is just like a level kind of a thing. Okay.
So you mean like you didn't divide
I didn't do it on this. You only divide it if it's greater than 1. If the length of the subsection is greater than 1, divide it.
Well, what I mean is when you have 3, 4, 7, 5, 9, 8, like
Yeah.
how do you divide that in half? I guess.
Because
yeah.
it's size 3?
Yeah.
So I guess you go from the middle, from the half of 3. So size is 3, right? And what's half of 3?
Because that's 1.5.
Okay, so I'm going to floor that and make it 1. So I'm going to cut it up into 0 to, well, 1, but you don't include 1, right? And then 1 to 3, but you don't include 3, so 1 to 2. Okay, that was confusing.
I forgot. When you divide it in, is it floor or does it round up?
You floor it. If it's 1.5, it goes to 1 in Java. And that's kind of the standard I'm using for integer division.
Or like the thing you were talking about, the array slicing.
Yeah.
The first part is inclusive and the second part is exclusive.
Yeah. So the second part is inclusive, but the first part excludes the middle, like the half point. Does that make sense?
Well, I don't know what you guys were just saying.
Write out the index and
Yeah.
then show it. 347.
347.
1, 2.
0, 1, 2. So this is 0, 1, 2, and this is a size 3, right? So half of 3 is 1.5, but when we floor it, it's 1.
Okay.
So the right half includes 1, and the left half does not. So that's the idea.
Oh, okay.
Okay. And of course, when we're going to work with the new array, since it's a new array, we restart it. We restart the indexing.
Okay.
Okay.
Cut 0 off, essentially.
What do you? Yeah, we just cut it off. Yeah, we cut it off. We cut 0 off from this big array. Okay. So I was here, right? We said J was smallest. So now J is outside. So that means we're done. So let's say we're no longer looping through one of the arrays. What do? So, okay, yeah.
Or you just return the value and then.
Well, we still have to work on this one. This is still missing some values. So we finished looping through one half of the array, right? So this is done, but this one's not done. So we have to keep on adding values that were left over from this. Or maybe it was this one. So that's the point. Then we add 9. Okay? And then we're done with this. So our original value was 9.8, right? But now we have a sorted list here. So let's fill up the actual array slice subsection with these values. So then you overwrite them. Right? And you get this. And that's what you return. And then we're in this. Wow. Can you throw it over here? Actually, I may not even.
Okay.
Damn, that was embarrassing. All right. So basically, we worked on this, and we turned it into that. Okay? I was going to go further down, but I can't go further down, so I'm going to work back up. So now we're working with this and this, right? So, not this.
So when it returns, like where does it go?
So we're going to use recursion, right? So we're not actually making a new array. We're indexing the original array. I'll show you what I mean. So now we're working with that one, right? So we're working back up, and we're going to make a new array. And the new array is going to be the size of this one plus the size of that one, right? Because that's how we're going to do it. So then, of course, we have I and J. Okay, and then we do the same thing. So now we compare, right? Which one's smaller, I or J?
Okay, I.
Yeah, so basically, and I go outside. So we're done with this one. So now what?
We know that J is already sorted, so you can just add it.
Well, we know that because we already know that recursively, like both of these arrays or these parts, these halves, are already going to be sorted. So that's the idea. We just keep putting them in there. We keep inserting them. So 8. And then we just keep iterating through this one. And there's nothing to compare it to, so just keep filling it up. All right? So now we have the copy. And now we fill these values into that half. 8, 9. All right? All right. This is a coincidence. I didn't know this half was already sorted. But let's just say we did it for this half, right? We did all of that, but on this half as well. Okay? We'll just assume that we did. So then now what do we do with this half and this half? Same exact thing we did here. So actually, How much time do I have left?
30.
30 minutes? Okay, I have enough time. Right. J. And then, of course, a copy array the size of that big one. Okay. All right, so let's go together, right? So what do we put? What's the first thing we put? 3.
So we have to compare 3 to everything.
Yeah, so we actually compare 3 to this value here, to the value in this array. And then once we see that this is the smaller one, we insert it, and then we move this up. And when we keep doing that, we see that 4 is still less than 5. 4, move that up. And now this one's the smaller one. So now we put this one, we move this one up. Right? Now this one's the smaller one. We put this one in here. And now we're done with this half. And what was the thing? What do we just always do when we have one more array left to fill in? Yeah, just add it. Yeah, add the rest, and that's it. And now we take this, what we worked on, and we just fill it up there. 3, 4, 5, 7. And I'm just going to write it again. Okay. Okay. All right. So are we like confused? Are we on the right track? Any questions about this? What we were just working on?
Can you explain the recursive?
Yeah.
I think it'd be easier to just
Well,
explain the recursive aspect.
so the recursive aspect is basically this, right? We recursively break it in half, right? This is the recursive part, breaking it in half, and then keep on breaking it in half. And then recursion stops at the base case, which is that the size is 1. So when the size is 1, like that's it. And then once you exit recursion, right? Then, so like when we were here, right? We had an array or a subarray that was size 1 and 1. And now we want to see the previous recursive step, it was size 2. So now we do like that thing, where we fill up a copy array, and in terms of like looping through both and comparing, and then putting it in order. We're merging these two in such a way that we have a sorted list.
You're not actually making a new array, right? Just like
We actually are. That's the thing. That's what this red thing is. This is a new array that we're filling up, and then once we've filled it up to the point where all the value is stored, then we store those into the actual array itself.
there's probably like a second array.
Yes.
equivalently sized.
We are making a auxiliary memory. We are taking up additional space. Yeah, we are making up additional space in this solution. That's the idea. Is there any questions in the chat? Oh, okay.
So technically, you make 2 arrays, and at the end you're basically just replacing array number 1.
Yeah, with the merging of the 2 smaller
so
ones.
basically you're taking the values of array number 2 and you're just basically
Yeah,
making new values. into
you're making
array
new
number
value. Yeah, you're adding them up in terms of like big, smallest to biggest.
Right.
Yeah.
You're doing all the math in K.
Oh, I just never use K. I just kind of visualize it. But we're gonna use K writing the algorithm, which is gonna be pretty long. Not gonna lie. This is the recursive part, and then when we're done with the recursive part, we do this looping, right? We loop through both arrays to fill in this new copy. And this is merge sort, but this part here is merge. Does that make sense? This is a completely different process from breaking it up. Okay. Um, okay. Okay. Should I leave that there?
I like it.
Yeah.
That looks good.
I hope I have space here
You have another board.
on the other board.
The camera doesn't.
That's the thing. The camera can only see from here to
Yeah, that
there.
stuff's right over there.
So it starts from there to there.
Board kinda sucks. Kinda like an arrow.
This board is just fine. This board is fine the way it is. So let me do it here. So I'm gonna do Python list partitions, splicing. Yeah, you don't do this in any other language except Python. Actually, uh, I'm just gonna do that
Is
instead.
that L? Alright.
Yeah, you're right. LR. Yeah, thank you for.
That wasn't the
Gotcha.
correction, that was pointing for the one.
Yeah, yeah. And, oh wait, actually, maybe I should make this words. Okay.
I can understand that.
Okay, yeah. That's should have just done that. If okay, so since this is recursive, we need a base case. So if beginning equals end, we don't run it at all. All right. But if beginning does not equal end, so the beginning is going to be less than end. What does that mean? Well, this is an index. These are indices, right? And if they were equal to each other, that means we're in this part right here. And we don't want to go down further. We want to go back up.
So if it's a one, if it's just a one thing array, then obviously it's,
You
you don't need to sort it.
don't need to sort it at all. It's already sorted by the mere fact that it only has one element. So it's not equal, right?
How is n defined? Is that just
N minus one.
Yeah, pretty much. Yeah, it's n minus 1. Actually, before I get onto that, we need to get the middle. So what's the middle, right? It's the average of these two. So the average at the beginning and the end. So let's say the average between 0 and 5 is what?
2.5.
So that's 2.5, but we floor it. Yeah. So middle equals beginning plus n divided 2. But remember, it's going to get floored, so it's going to get the point away.
in Python? Does that floor it naturally, or you have to stop?
Yeah, right. Yeah, you're right. You have to actually, in Python, put the extra 1. That's going to floor it.
So I actually don't know that. It's the 2 division marks makes it floor.
Mm-hmm. 2 division mark makes it floor. It turns it into a double. But if you put a 1, it'll turn it into a double. So yeah, that's the nuance.
So Python doesn't use integer division?
It does.
It, yeah, yeah. So yeah, in Python it's a little different. It turns it into double when you're dividing, and then you get a value that isn't like.
It'll just be 2.5.
That will be 2.5 if I did this. Okay, but we're doing that. So it gets 2. So then we get the middle. And then see, here's the recursive part. R.
Sorry, so you said it would be 2.5, like
If I remove this, it'll be 2.5. But now that I'm doing this, it's gonna be 2. You know, yeah.
Is it still a double? Or
Hmm?
does that set it to be an integer instead? Yeah.
What do you mean?
Wouldn't it be a double or an integer if you split double slash? Would it just be a double set to 2? Or would
Oh, okay, so this is integer addition, right? This is gonna be an integer. But if you divide an integer by another integer, and you don't get a clean like integer number, it's going to give you that double. It's going to give you the point. I'm doing this so that doesn't give me the point, and it takes out the 0.5. Okay, so merge sort is R beginning mid. Okay. We have questions about this part right here? What am I doing here, up to here?
So is that the recursive aspect where it calls on itself?
Mm-hmm. Mm-hmm.
Okay.
That's exactly. It calls on itself. See, when I was cutting it up, it was calling on itself. I'm cutting it up into halves. So array goes beginning to mid. So see, it was going beginning to end. But now I'm going to the middle. It goes from beginning to middle. So I'm partitioning it. And I'm going from middle plus 1 to end. Okay? So these are both halves. So let's say we do that and it goes down, all the way down, and go back up, and we're at this point. So basically, what this is going to do is that this is going to sort the first half and the second half. So now after this, both halves will be sorted, but the whole thing may not be sorted. So now we have to merge. We have to merge the array. So I guess I could put both beginnings. See, I think it's beginning to end. I could do that. Okay. And then I have to make another merge algorithm. Yeah. Is this wrong?
I think so. I think you could create variables for the merge sort. So it's the return an array. So from beginning to middle, you just save that sorted half in a variable, and then the other half in another variable.
Actually, I was thinking that like maybe the purpose of this is just to like, we're going to do this again in here, and then that's gonna be like where we're gonna partition it, and then we're going to actually, yeah, you got a point. You got a point. So where is it? Actually, no. Why am I erasing this?
I don't know.
Why am I erasing this? But then where do the variables come from?
What do you mean? You create a variable. Like let's say left is equal to merge sort array beginning mid, and then
Left
right.
array, right array. Is that what you're saying?
Yes, and then merge. You send them both left and right, and it will merge.
Oh man, that's actually a good point. Actually, we don't really need to do that though.
Huh?
We don't really need to do that. We could just do it in place.
You can do all this in one function.
That is true.
So where's the code end, like after these merge sorts? Is it recursively calling itself?
Yeah, it's recursively calling itself until beginning equals end. Once beginning equals end, the size is 1, so you
it's not
stop.
gonna get to merge until it's done recursively calling itself.
Yeah, so yeah, merge is gonna, like the last merge is gonna be like the whole thing, merging the whole thing.
Yeah, you can save it in left and right variables, and then return, merge, left and right.
But what I'm saying is that, look. I guess now I'm arguing with Lazaro. I'm arguing with Lazaro, guys. I am arguing with my co-lead, guys. I mean, I don't know. This is what I was thinking. And you're right, it is goals. So what I was thinking, Laz, right?
Tell me, David.
So the middle would be the beginning plus n divided by 2, right? And then we would, so say I, j, k, equals 0. So I is going to be the iterator for the left half. So it's 0. So the first one is 0. And then j,
Yeah,
middle plus 1. And then k is 0. Oh, and of course,
Isn't K an array?
well, k is going to be the iterator for the third array, which is going to be the copy that we were doing, the red copy. Remember? The red copy. So we're going to make an extra array. Array copy. Okay? And that's going to be integer array of size, well, n plus 1. So it's going to be.
Okay, hold up. Now you're confusing me, man.
I'm confusing you?
Here you're passing in array, right?
Yeah.
Which array? It's array the size of those two halves together. So you don't need an array copy. You can get you're reusing array, and since you have I is equal to 0.
No, 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 no. So I'm saying that within the actual array itself, both halves are already sorted. So like it's sorted from here and here. All right? And we're merging them now.
Okay.
So I'm making an additional array of sizes, well, I guess it will be the whole thing. And so we're going to fill up the array in order, right, of the values of both the left and the right half. Okay, does that make sense? Or no?
That's fine. Okay. Okay.
Okay, so then I'm going to do it in Python again.
But you're only getting one. How come you're only getting one array into this function?
What do you mean? Oh, this is going to be our copy.
One argument is array. So
Yes,
the array assumes
the
they're
original
both
array.
together.
Yes. Yes. Yes.
Okay.
This is a different way of doing it.
Okay.
Okay, if you want, you can come up here.
No.
I mean, yeah, he wants to come up here.
I don't.
He does. He does. All right, this is kind of funny. It would be end minus beginning plus 1. Plus 1. All right, are we confused about this part right here?
Wait, 0 times n.
Okay, so this is, okay, so in Python notation, this is a list, right? Right? So it's a list with only one value and it's 0. But let's say we, copy this value, we store it this many times. That's the times. It's
Like the length of n beginning.
yeah, so this is the length of the list and they're all zeros.
That's like equivalent to n of the new array.
Right, so that's like,
You should just write like a comment on the side. I think for non.
yeah.
Especially people on at home.
Size equal to, no, I just kind of, I kind of just put it before the line.
That's great.
Okay, so the size is the n minus the beginning plus 1. Okay, yeah, what's your question?
Okay. When would beginning not be 0?
When will beginning not be 0? Actually, that's a good point. You're right. You're actually right. You caught me on that one. Okay, thank you. So basically, I would start at beginning, j would start at mid plus 1, because then it would be j would iterate on this side and I would iterate on this side. Are we confused about that?
Are you declaring variables right there?
Yes, I am.
Okay.
This is the Python way of declaring, you can declare variables like I is going to be this one, j is going to be this one, and
So I is assigned to whatever k is assigned to. In that way.
I is assigned to so the first one here is assigned to the first one on this side.
Okay.
The second one here is assigned to the second one on this side, which is mid plus 1. And then k is assigned to the third one, which is 0. Okay. Yeah, Python is weird. Do you want me to actually do it line by line?
You should just for not.
Okay, all right.
Okay, my bad.
I'm gonna do it. I'm gonna do it.
I'm confused. I don't know Python that well. Sounds like a
That's mean. That's mean. That's really mean, man. We don't appreciate toxicity.
I don't know. Maybe. I don't know anything.
Can you declare like variables, multiple variables in one line?
Yeah.
Java?
Does that work like that though?
Yeah. You can. Well, I mean, one line. Well, actually, yes, you can. If they're all the same type, they
Yeah,
can all be on the same line. But well, in Python, you don't declare type because that's, I don't know, that's just how it is. J is the iterator for the second half.
Yeah, because he's doing Java now.
Oh, he's doing Java now?
I don't need to read Java. I just need it to be easier to look at.
Actually,
It's fine,
hold
okay.
on, hold on, hold on, hold on. Because the J looks like a semicolon, so I'm not gonna draw the J and the semicolon on the same. What was it? Mid plus 1. And then K is equal to 0. Okay. All right, there.
Thank you.
There. All right, no problem. So then now after this, you have to write a for. Okay, yes, 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 yes. Yes. Come up here.
No, okay, I'm just, like, because I'm
I only scream at my co-lead, by the way.
Yeah.
I only scream at him.
Wow, we're so friendly, guys. Okay, so that merge sort function, so is that supposed to be doing the dividing part, and then merge is supposed to be doing the merging part, the conquer part?
Yes, so this is the dividing part, and then this is the conquer part. All right?
Okay.
So we're cutting up, and then, once we get out of these recursive calls, we're going to merge, each of the halves of the array are going to be already sorted, right? And then we just, merge them together, and then the whole thing is going to be sorted by the end of this call.
Okay, so here in merge sort, let's say we're in the second level of the recursive tree,
Oh, okay.
and let's say we're looking at 798. That's already sorted, right? Let's
Seven.
say we're looking at 798. Thank you.
7.
9, 8.
Okay.
Okay. Let's say we have that as our array,
Yeah.
right? You're calling merge sort to continue breaking it down, right?
Yes.
But then you're calling merge and you're passing 798.
Yes, I am.
Okay.
Well, look.
It has to be sorted by then.
So you
Yeah,
know-
they're already sorted.
Very fine.
That's the thing. They're already sorted. Both halves are sorted.
So you're doing it in place.
Yes.
Wait,
Yes, I am. But the merging part, I have to make an extra array. I have to make an extra data structure for the conquer part. I have to do that. That's
No, yeah, okay.
what I'm doing here. Okay. Yes, you.
So what are we using?
I didn't mean to say like yes. I didn't mean to say you.
Yo, this guy.
I'm sorry. I'm sorry.
Okay, fine.
I'm sorry. It's him. It's his
We
fault.
can
That's
replace
why.
him, it's fine.
No. We can replace him. I'm kidding. I'm kidding.
Yeah.
So
No, I'm kidding. Laz does a lot of hard work. Okay. go.
yeah. So what are we using K for?
K is going to iterate for this one. So K is going to be our indexing variable for array copy, for the copy. Okay.
Okay, sorry. I don't know. It slipped my mind a little. So what is it again? So we're using K so array copy is, I guess, the new one. that you created.
So when we're going to index a value for array copy, we only use K. We only use K. We don't use I or J to index values in array copy. That's what K is for. Are you so? Is this?
I think kind of. So why did you write I and J there?
Because I is going to iterate for the first half, and J is going to iterate for the second half. Because
So then you create the new one called array copy. Is that what it is?
yes, so we're creating a new.
Basically, the I and J that you wrote is. to
Yes,
do array.
before. Yes,
Oh, okay.
that's what we were doing before. Yes.
Remember how he was comparing like I to J before, like on each side of the array?
Right. You mean when he cut it up?
Yeah,
right?
when he's kind of
Okay.
merging.
Okay.
That's what-
All right.
that's what he's
Yeah,
gonna
I know.
That's what he's writing.
Can we go over time in the room? We
In
can.
the room, yes.
Okay.
Who uses this?
But we can still go over time.
Yes, yeah.
All right.
You just try to keep
All right, guys. I'm gonna spend a little bit more time on this now, or I might just continue the next time. All right. So yes, the I is iterating through here, and J is iterating through here. Okay. All right.
Okay, yeah. Okay.
Okay, and then k is supposed to iterate through the whole copy. All right, so now we're going to fill up array copy. And remember how we did it before? How did we do it?
The minimum of I or j.
Yeah, minimum of I or j. So,
So why do you put zeros then?
zeros?
No, because you said k equals 0, and earlier you were saying so.
No, k is just to iterate.
Oh,
The index.
sorry, my bad. Well, maybe I was thinking of, you said that initially, like, we create the array with zeros?
Yes, because when we initialize integer arrays, they're all zeros
Oh,
at first.
okay.
And that's what this is.
Right?
I'm going to treat this like a Java integer array. That's why I'm doing it like this. And that's, people like Java. I need more space to write the while loop. Okay. Yeah. I guess I'll write it here then.
Wait, can you do it on the right?
On the right? Wait,
Yeah.
on that side?
Yeah, that
Just draw like a line.
the same board, but just more on the right.
Okay. So while I is less than or equal to mid, or j is less than or equal to end. Okay. So I, again, why? Okay. So I is going to keep moving up, right? And it starts from here, and we want to get up to here. We don't want to get past this, because past this is where the other array is. Well, the other half of the array. And j is the same. J starts here, and we don't want to go after the end, right? Because then we go outside of this half. All right. So then array copy, of course, is going to keep increasing. So well, first, min index, same as before. It's going to be equal to I or j, right? It equals I if array I is less than array j, else array else j. Okay, yeah, this is Python notation again. And this might be confusing, but this is what it's doing. The minimum index is going to be I if the array at I is less than the array at j, right? So this is going to be a value at the right half, and there's going to be a value at the left half. So if the left half has the the smaller value, then the min index is going to be I. But if that's not the case, then we're going to set min index to j. And then we do a test, right? So now array copy equals, well, first we have to check if min index equals I plus plus, else if okay. So if the min index was I, we move I up. But if it was j, then we move j up, right? Because then that's what we were doing before. All right? And now array copy k equals okay. Then array copy equals array min index. So that's like the minimum value we found between I and j. And then k is moved up. All right. So then we're going to run into, so here we're moving both up. But it could be that I goes over first or j goes over first. So then, like, what would you do in that instance? What would you need to do? If you go over, if I goes over mid, or j goes over n, what would you do?
So, I mean, but it's supposed to stop, like, iterating, I guess?
Yeah, this loop is going to stop iterating when either, actually, no. You actually caught me on that one. They both have to be less than their limits, both. Okay, so then when I goes over or j goes over,
So it'll stop, right?
it'll stop. So then what do you do after that if we still have values left in one of the arrays? Or one of the halves, I mean.
And you just fill the rest in.
Yeah, you just fill the rest in, whichever one is the value. So you will write another while loop. And I might continue on the on this board because there's a lot of writing for this one. You got
Yeah,
the?
you're pretty good.
Okay. So let's say it was I, right? So if it was I, we just do this. And then k plus plus I plus plus. Actually, my mistake. And okay. So what's happening here? So I'll write this better. So if I is still less than mid, that means we're not done with the left half. So just fill. But maybe this never happens. So if this never happens, it must be this one. That means j, the right half isn't done. So we just fill. And that's it. This is the merge algorithm, right? Well, actually, we're not done. Now we made the array copy. Now we're supposed to fill the original array, right, from beginning to end with all the values of array copy. Okay? So then while, so we could make, so now k is going to be equal to the length of the array copy. Well, actually, we could just set, I don't know, n equals length of array copy, right? And then I'm going to set k back to 0 while k, actually k is 0, and give me a letter.
P.
P? R? No.
Z.
Z.
X.
X. I like X. Yes. X.
3 letters he chose are completely random.
I just chose them completely. I don't care. I don't care. I don't care. Okay. And so actually, and then I'm gonna put m is going to be equal to, so end minus beginning plus 1. So this is the length of the original. I mean, yeah, it's over there. I know.
No, n plus 1. Because the beginning is always 0, no?
They're both the same length. Actually, they're both the same length.
Yeah.
You're right. Well, you know what? Actually, why don't I just do this, right? Why don't I just and then I would just do that. All right. I didn't even need to do that at all. While, and actually I only need one. So while x is less than, actually just less than. Okay, so, and of course, x plus plus. All right, so what's happening here, right? So Basically, the size of the array copy and the size of the original array we're working on, they're the same. So we just say array x equals array copy x. Well, actually, now that I think about it, this has to be beginning. Yeah, this has to be beginning. Okay. There are some problems with this while loop, and I have just noticed there are problems with this whole thing.
Why not just return it?
Huh?
Why not just return array copy and then that's be returned there? You return it here in the merge function.
Well, I could just do the merge in place. I could just do the merge in place. I kind of want to.
Okay.
I just want to. You're always
That is gonna give
disapproving.
us some problems.
Okay, some logical problems. You can do it. It's just it takes a little bit of some brain work. It's some mental gymnastics, as opposed to just returning the left array and right array. Yes.
So, to clarify, what exactly are you trying to do with this part here?
Yeah, you know what?
Sorry.
Actually, right.
I know when you said that it's not like there's something wrong with it, so it's not correct.
No, it's actually correct. Actually, no. I know what I'm doing now. I know what I'm doing now. Y equals beginning. I got it. Okay, there we go. Right. The two variables. I finally got it now. So x is 0, so x is going to iterate through array copy. But y is going to iterate through the original array. Okay? So array y, right? So the index value is going to equal to array copy. So what I'm saying is that I'm going to, like before, remember when we had the red array and we just filled up the original array?
Yeah.
That's this part.
Hold on, sorry, wait, never mind. Why did I say yeah? What did you fill the original array with?
You fill up the original array with the values of the array copy. The array copy is sorted.
Oh,
Yeah,
okay.
this is
Okay, yeah, now I remember.
this
now.
part.
Okay.
Yeah, this part is going to return. The array copy is going to be sorted after these loops.
Okay.
That's the point. And then, since array copy is sorted, why not make array turn that into array copy, right? And that's it. That's all that this is doing. And then
so
one.
again, to clarify, all it is just taking array copy, which is the sorted array.
This part. Yeah, this part right here.
And basically, it's putting all that shit in the original array.
Yeah. We are live stream. Please let's
Sorry.
Well, actually, I don't think.
Since you were being funny, I just thought, okay, maybe add a little bit of humor.
To be clear, I have not made any vulgar words or statements because we are a professional community. No, it's not fine. We are a professional community. We are a Google community, so we are professional. But I don't think they heard you, so I think it's okay. I think it's fine. Well, they didn't hear what they said. They didn't hear what he said.
But you didn't help. It's fine.
Yeah, it is fine. You know what?
No,
You
like
always
I said, I only did that because like you started.
It's okay. It's fine. It's fine. It's fine. It's all right. It's okay. Yes, it was funny. It was.
Yeah, because you started being funny and yeah, I figured people like humor, so you know.
It keeps them engaged. It keeps them engaged.
Oh no, definitely.
Yeah, it keeps people engaged when I can do this stuff. Okay. So, any questions about everything we've done so far? Any part? Yeah, you. I know you're the one that criticizes
Okay,
me.
what was your else statement there?
What do you mean? Where?
Like here, do you need an else?
Here?
Yeah, yeah.
No. This is our recursive part right here. This is our base case.
Okay.
The base case, if that is beginning equals n, that means the size is 1. So we don't call merge sort. We don't do anything. But if beginning does not equal n, that means it's bigger than 1. So we would recursively call merge sort again. That's the point. That's what this is for. That's what this is. All right? Now, I wanted to get into Quicksort, which is my favorite sort, but I know now we don't have enough time because This is a pretty long lecture. I think I am going to end it here, but there was a problem. There was a leak code problem. Yeah, thank you. That it was sorting an array. That was in the beginners. And this is one possible answer to give. Or you could just erase that sorted, and that also does it as well. But that's taking the easy route. You know, developing something like this, and knowing how divide and conquer works, like that actually makes you sure of these concepts, that you can explain them and that you can use it to solve more complicated problems. And yeah, this is merge sort, which the runtime of this is big O of n log n. Okay. The log part is because we break the array in half this many times. Log of n, so let's say it's size 6. We will break it up log of 6 times, which is about 3. It's 3. So it'll be 6 times 3, 18. So instead of doing 36, we did 18 in terms of running this algorithm. And the recurrence relationship is T of n is so this is the recurrence relationship. So we run the recursively twice. We do it 2 times, and each time we cut it in half. That's what's going on there. Yeah.
Would it be faster to create your own merge sort algorithm instead of using the built-in merge sort?
You mean the one in the?
Like, would it be faster that way, or?
You mean to make your own merge sort, or use the sorting algorithm
and
that
then
the language has?
Yeah.
It's actually the language is actually faster. That's because they're geniuses, so they developed it. They made it. They know how it works. So
Right.
it's like a mix of merge and quick.
I'm just asking because some algorithms you can actually build them to do the same thing.
Yeah.
Faster.
Yeah. So this one is the thing about this one versus Quicksort is that this is reliably n log n. Quicksort is not reliably n log n, and I'll go more into detail next time briefly because we have other things to talk about when it comes to arrays. But yeah, that's it for today's lecture. And
What are the other things that you'll talk about?
right, next time we're gonna talk about. So now that we sorted the array, what's the faster way to look for elements in the array? So we're gonna talk about binary search, and we're gonna talk about different data structures like stacks and queues. And how different they are from arrays. So it's next Wednesday at 3:30, and do be sure to do the leak code questions. They really do help with knowledgeability and your problem-solving skills. And also, we will talk about this later, but be sure to look out for Friday night's binary search competition. So we're gonna collaboratively work on coding problems together at 8 to 10 p.m. Friday night over the internet. And we'll do it on the Coding Dojo voice channel on the Discord server. All right?